You've been there, right? You click a button in an app and the whole thing just freezes. Or worse, it crashes. Well, it turns out that building modern, huge applications is this constant fight against that kind of fragility. Today, we're going to dive into a massive shift in thinking that helps these systems stay alive, to stay responsive, even when things inevitably go wrong. It's all about moving from a fragile chain to a resilient network.
It happens all the time, and it's so frustrating. You're just trying to buy something online, and one tiny hiccup somewhere deep in the system causes a total meltdown for you, the user. This isn't just bad luck, you know. It's usually a direct result of how the different parts of the app are forced to talk to each other.
And this is where it all goes wrong. Think of each service here as a domino, lined up perfectly. Your request tips the first one, service A. Now A needs something from B, so it just stops and waits. B needs something from C, so it stops and waits. But then, boom, service C fails. Because A and B are both stuck waiting, they fail too. The error just comes screaming all the way back to you. This is what we call temporal coupling. It means everything has to work perfectly at the exact same time.
And that right there, that has a name. We call it the domino effect problem. It's the Achilles heel of what are called synchronous systems. Synchronous is just a fancy way of saying things have to happen in a rigid sequence, where each step has to finish completely before the next one can even start.
I love this slide because the analogy is just perfect. A synchronous request, it's a phone call. You dial, and you are literally stuck on the line, waiting for an answer. If the other person's busy or just doesn't pick up, the whole call fails. Your time, your resources, wasted. Now contrast that with an asynchronous event. That's like posting on a message board. You write your message, you post it, and you walk away. The other person can read it and deal with it whenever they're ready. You're not blocked. You're free.
So that message board approach, that's the heart of this really powerful solution called event-driven architecture, or EDA for short. It's a total paradigm shift. We stop commanding services to do things, and we start simply announcing that things have happened. So let's break down the key players in this whole new world.
First things first, the absolute fundamental piece, the event itself. Now this is key. An event isn't a command. It's not, please place an order. It's a statement of fact. Order was placed. It happened in the past. You can't change it. You can't reject it. It's an unchangeable record of something that already occurred.
Next up, we've got the producer. This is the service that sees something important happen, like that order getting placed, and its job is to create the event. And here's the magic. Its job ends right there. It just shouts the event out into the world, totally unaware and frankly unconcerned with who might be listening.
So who is listening? Well, that's the consumer. A consumer is a service that subscribes to specific types of events that it actually cares about. When it sees that order was placed event fly by, it might kick off its own private workflow, maybe updating inventory or sending a confirmation email. And you could have 1, 10, or 100 different consumers all reacting to that same single event completely independently.
And what connects them all? That's the event broker. This is our message board. It's the central nervous system for the entire architecture. Think of it as a piece of infrastructure, something like Apache Kafka, that just reliably grabs all the events from all the producers and holds onto them, making them available for any consumer to read whenever it's good and ready. Now, just switching to this model doesn't magically solve all your problems. It introduces some new, unique challenges. So architects need a specific set of patterns, a toolkit really, to handle things in this new asynchronous world. Let's look at a couple of the most important ones.
Okay, one of the first and most dangerous traps you can fall into is something called the dual write problem. This happens when your service has to do two things that absolutely have to succeed together: save a change to its local database and publish an event telling everyone else about it. Just look at how this can go sideways. The service successfully saves the new order to its database. Great, step 1 is done. But then it tries to publish the order was placed event, and the network glitches. The event broker's down. The publish fails. What's the result? Your whole system is now in an inconsistent state. The order exists in one service's database, but no other service, not shipping, not billing, nobody will ever know it happened.
So how do we fix this mess? With a really clever pattern called the transactional outbox. Instead of 2 separate risky steps, the service does only one thing. It saves both the order data and the event data together in a special outbox table, all inside a single atomic database transaction. Atomic just means it's all or nothing. Then a totally separate, super reliable process comes along, reads from that outbox, and makes damn sure the event gets published.
Consistency is saved. Okay, but what about really complex things that involve multiple services, like booking a whole vacation package? For that, we use something called the saga pattern, and it comes in two main flavors. Choreography is like a well-rehearsed dance. The flight service publishes Flight Booked, and the hotel service just knows to listen for that and do its part. Orchestration is more like an orchestra with a conductor. A central service literally tells the flight service, book the flight, then tells the hotel service, book the room. They both have their trade-offs, right? Between loose coupling and how easy they are to debug.
So, we've got the concepts, we've got the patterns, but what about the actual technology? Choosing the right tools, and more importantly, knowing what vital signs to watch is absolutely critical if you want to build a system that's truly resilient.
In the event broker world, you'll hear two big names a lot, Kafka and RabbitMQ, and they work in fundamentally different ways. RabbitMQ is like a smart post office. It knows about every individual message and deletes it once it's been delivered. It's awesome for really complex routing. Kafka, on the other hand, is more like a dumb but incredibly fast logbook. It just keeps it pending events, and it's up to the consumers to keep track of where they are. Its superpower? Insane speed and the ability to replay history, which is something a queue-based system just can't do.
All right, let's talk about system health. Imagine you log into your monitoring dashboard first thing in the morning and you see this huge number, over 1.5 million. What does that even mean? Is that good? Is it a complete disaster? Well, this number represents one of the most vital metrics in any event-driven system.
That number was consumer lag. Simply put, it's the number of messages your consumer is behind the producer. It is a direct measurement of how well your services are keeping up. If that number is steadily growing, you've got a problem. Your consumers can't process events as fast as they're being created. It is, without a doubt, the pulse of your entire system's health. Look, event-driven architecture gives you incredible power, amazing scalability, and true resilience. But all that power comes at a price. It is not a free lunch. It demands a whole new level of discipline and a different way of thinking from your development teams. To really succeed with EDA, you have to nail 4 things. First, radical observability. When a request bounces between dozens of services, you need tools to trace it, or debugging is impossible. Second, data governance. You need a central rulebook for your events, a schema registry, to stop one team's change from breaking everyone else. Third, your consumers have to be idempotent. That just means they can handle getting the exact same message twice without messing things up. And finally, and this is a big one, teams have to get comfortable with eventual consistency, accepting that the data isn't always instantly the same everywhere. Which brings us all the way back to the core choice you make when you design a system. By moving away from that synchronous command and control world to an asynchronous react and respond one, you fundamentally change what your system is. You go from that fragile chain of dominoes to a resilient network of actors. So the real question you have to ask of any system, including your own, is this: is it built to react, or is it just built to break?